This video, we're going to talk about some double angle identities, some half angle identities, which are related to our power reducing formulas. So we haven't gone over yet, but you can see that if sine of theta would be equal to 1 minus cosine of 2 theta over 2, then this is because sine squared theta is equal to 1 minus cosine 2 theta over 2. And cosine squared theta is 1 plus cosine theta, 2 theta over 2. So we just make the replacement there of theta with theta over 2. And bam, we have our half angle identities. We have to pay attention though to whether we're in a quadrant where the half angle is going to have a positive or negative cosine value. We have to make that choice. So in our first example here, our theta is in quadrant 1, which means that our half angle is going to be in quadrant 1 as well. So root 15, there's my theta. So theta over 2 is going to be between 0 and pi over 4. So sine of theta over 2 is going to have a positive sine value, positive root 1 minus cosine. And I'm going to multiply by 4 to get rid of the complex fraction there. Now I'm going to multiply by 2 over 2 to get a perfect square in the denominator here. And there's our answer. We're going to have the same triangle again here for 22. This was 21. Right, 22 here. So 22 is going to be cosine, which will also be positive in this range. It's going to be root 1 plus root 15 over 4 over 2. So the only thing that changed in this whole problem was that the minus became a plus. But all the other steps remain the same there. Now we're going to change the problem up slightly. It's still going to be the same triangle, but we flipped the sides. So now this is the root 15 is up here. And we want sine theta over 2 is going to be 1 minus quarter over 2. So we're going to make this 4 minus 1 over 8, 3 over 8, multiply by 2 over 2, 6 over 16 is root 6 over 4. Same triangle here for number 24, only they want us to find cosine of theta over 2. So 1 plus a fourth over 2 is going to be 4 plus 1 over 2, be root 5 over this is 8 over 8, and then times 2 over 2. It's going to be root 10 over 4, like so. Let's clear the canvas. We got a different triangle now that's going to be in quadrant 3 for our theta. -3, 5, -4. Let's take a peek here that if theta is between pi and 3 pi over 2, then theta over 2 has to be between pi over 2 and 3 pi over 4. So it's in the top half of quadrant 2. That means that the cosine value is going to be negative there. So I'm going to have to choose a negative square root 1 plus cosine over 2, and negative root, I'm going to multiply by 5 over 5 here. 5 minus 4 over 10 is 1 over 10. It's going to be a negative 1 over root 10 is a negative root 10 over 10. Let's clear this. We're now in quadrant 2. Because cosine is negative and sine is positive, so that means that theta is between pi over 2 and pi, which makes theta over 2 between pi over 4 and pi over 2. So it's in the top half of Q1. So everything's positive there. Cosine of theta over 2 is going to be 1 plus the cosine value over 2, multiplied by 5 over 5. 5 minus 3 over 10. 2 over 10 is 1 over root 5 is root 5 over 5. If sine is negative and in quadrant 4, theta is between 3 pi over 2 and 2 pi, and theta over 2 is between 3 pi over 4 and pi, which is in the bottom half of Q2. So sine is going to be positive there. 1 minus the cosine value here is 4 over 5 over 2 is 1 over 5 over 2 is 1 over 10. It's 1 over root 10 is root 10 over 10. Just a few more problems in this section. Secant theta is negative 25 over 24, which means that cosine theta is a negative 24 over 25. Theta is in quadrant 2. 24, 25, 7. That forces theta over 2 into a region of pi over 4 to pi over 2, which is the top half of quadrant 1. So sine of theta over 2 is going to be positive. It's going to be 1 minus this cosine value over 2. It's going to be 1 plus 24 over 25 is going to be 25 plus 24 over 50. It's going to be 49 over 50 is 7 over 5 root 2. 7 root 2 over 10. We're going to be in quadrant 4 again for this one. And the sine value is negative 20 over 29. I think that makes this 21, but let me check. 29 times 29 is 81. 18 is 26. This is 58. And the square root of that is let's see. Right. Right. Minus 400 is 441, which is 21. Okay. And I need to find that the half angle here is between 3 pi over 4 and pi. So that's going to be the bottom half of quadrant 2. And cosine is going to be negative there. So cosine of theta over 2 is going to be a negative root 1 plus this cosine value over 2. That's going to be cosine theta over 2 is a negative root 29 plus 21 over 2 times 29 is a negative root 50 over 58. Negative root 25 over 29 is negative 5 over root 29. The negative 5 root 29 over 29. Just two more problems. Cosecant is a negative 4/3, which makes sine a negative 3/4. Tangent is positive and sine is negative. So I'm in quadrant 3 for theta. 3, 4, 16, 9, 7. Yeah. And then half angle, if theta is between pi and 3 pi over 2, then theta over 2 is between pi over 2 and 3 pi over 4. So we're in Q2. And cosine is going to be negative there. 1 plus cosine is negative root 7 over 4 over 2, negative root 4 minus root 7 over 8. I'm going to multiply this by 2 over 2 to rationalize that denominator. 8 minus 2 root 7 over 16. All inside the square root is going to give me a negative 8 minus 2 root 7 on the top and a 4 on the bottom. And one last problem for this set. We have cosine is a positive 4/5. We're in quadrant 4. 4/5, that's a negative 3 there. If theta is here, and theta over 2 is there. So we're in Q2. And cosine is going to be negative there. Cosine here is 4/5. 5 plus 4 over 10. 9 over 10. 3 over root 10. Negative 3 root 10 over 10. Okay, that's it for this video. We'll come back next time and we will use some half angle formulas to figure out the exact values of these here.